In this series of videos, we're going to talk about advanced loops in Java. In our previous video, we introduced loops, and if you'd like to see that video, I will put the playlist for all of these videos in the comments. In this video, and probably a couple more that will follow, we're going to talk about loops. We're going to talk about old school arrays versus a more commonly used array list now. We'll talk about nesting loops. We're going to have a for each loop inside of a for loop, or sorry, other way around, for loop within a for each loop. We're going to demonstrate the break statement, and we'll talk about multi-dimensional arrays. As I mentioned, this might happen over a series of videos. We'll see how long it goes. So first, I'm going to go to the project that I've been using, and this is on GitHub. I'll put the GitHub link in the comments as well. I am on a new computer, or one that I didn't use in the previous video, so I'm going to select the project, and very quickly I'm just going to do a remote pull to make sure I'm up to date. You're welcome to do this as well with the Git link, which is here, but again, I'll put that in the video comments as well. So give this a moment to update, and we're up to date. Okay, so I'm going to go back to the driver project, the driver class we've been working on, and what I'm going to do to demonstrate these advanced loops, we already are looping to create a series of vehicles. We're assuming that we're going to run each vehicle for a given distance. We're only prompting for distance one time. That's the thing we're going to change. We're going to prompt for distance for multiple trips, and then we're going to run the vehicles for multiple trips. So let's focus. I'll double click so we can focus on this. First of all, if we take a look at trips, we see that we're currently prompting for a distance to travel, which is an int, a primitive value. So what I'm going to do is I'm going to create an array to hold these. Now, I've created arrays before, old school simple arrays, not array lists. And honestly, I don't tend to use arrays a whole lot. I tend to use array lists more because array lists grow dynamically, which is quite nice. So this is an array list on line 35. But there again, my preference isn't everybody's preference, so you might be working in someone else's code where they use an old school array, or on a very memory constrained device like a mobile device, the old school arrays with primitive data a lot of times make sense. So I'm going to say int trips, and you know what I'm going to need to do is I'm going to need to use the square brackets to indicate that we're using an array which is going to store multiple pieces of data, not just one. Now, the trick with this is that I want to initialize it to new int like so. But we remember when I do this with an array, I have to put a capacity on the right side, how many elements I wish to store in this array. And this is where array lists have an advantage. You don't have to specify the capacity in advance. Again, by array list, I mean this newer construction we see down here, not what I'm doing up here. With an old school array like we see here, you have to tell it in advance how many times, what capacity you want to have. Now, we're probably not going to sit here and enter 100 trips. So what we'll often do with an old school array is we'll have a counter variable as well that determines of these 100 trips we could take, or of this 100 space capacity, how many am I actually using? So I'll say int trip counter equals 0. So that's what we'll call a companion variable. It says, okay, we're setting aside 100 spaces in this array, and then this counter, each time we take up a space, we're going to add 1 to the counter so that we know how many spaces we've taken up. Okay, now back down here to our prompt user method, and we see that this method is getting pretty long. It's probably a good time to start thinking about how we can refactor this method and maybe introduce some new methods. But nonetheless, what I'll do is I will take this part where we're prompting the user for a distance to travel. I'll take this and refactor this into a new method. Refactor, introduce, and we're going to say method. Okay, we'll call this prompt for trips. Okay, and you see that it has replaced our 2 lines that were here before with a method call. Now, actually, I'm going to go ahead. One thing I don't like, though, I'm going to remove that int because I don't want it to return int. I want it to just add these trips to our array. So I'll change the return type of the method to void, and I'm also going to remove the parameter that follows return and just shorten that to return as we would for a normal array. Okay, now what we'll do is we'll do our friend the do while loop. So we'll start with a do and close with while. Remember, a do while loop is guaranteed to run at least once because the test is at the end. Now we've made a do while loop before, and if I scroll up, we'll remember how that works. We use this J option. Well, the test is down here. The way I did it is I used a J option pane.show confirm dialog to ask the user, do you wish to create another car? So we'll do something similar. As a matter of fact, I'll just copy this whole block, these few lines here, and I'm going to paste those down here. I'm not done yet. I know I'm going to have some more things to do. One is that create another. Well, one is my method looks really sloppy now and I have a couple red lines I need to take care of. But remember this create another. This is going to hold a definition of which button the user clicked on this show confirm dialog. In other words, the show confirm dialog is going to show a yes and a no option, and the create another variable will hold that choice that the user made. Now, while it has the same name as the variable that we used in the upper do while loop, it's a different variable, because remember what variable scope means. Variable scope means the variable is alive from the point at which it is declared until the end, the close curly, of the block in which it is declared. So this highlighted blue area is the point at which create another is alive. And you see it's not alive down here in this prompt for trips method. That's a different method, that's a different scope. So we can go ahead and declare it again and have a completely separate place in memory because of that variable scope. So I'll say int create another. Honestly, we can just terminate, we can just declare it. So I'll put some comments to this in just a moment. But nonetheless, you see that we have finally taken care of the red lines in this method. So Shift-Alt-F, remember that's our best friend in NetBeans. It will do some automatic tabbing of the methods for us, makes it look really nice. Okay, now because I copy-pasted this, I do need to change the text that's here. So instead of do you want to create another vehicle, do you want to create another trip? Okay, change the title as well. Trip. There we go. Everything else looks fine. It's going to be very similar. Okay, now we have here enter distance to travel. Okay, and then we're parsing that into an int. What we need to do next, let me just put some comments here before I forget. Prompt the user for a trip distance. Okay, now we'll say store that trip distance into an array. Okay, and what was our array? It was called trips. So I'm going to say trips, and then square brackets equals int distance. But I have a problem here. In the square brackets, I have to tell it which compartment of this array I want to store this data in. In the previous video where I talked about what arrays are, I kind of said they were like floors in a building. But European style, where the ground floor is actually floor 0 in Europe, where in the US we tend to call it floor 1. So similar thing with arrays, we start counting at 0. So okay, I could put a 0 here, and I say trips 0 equals int distance. Okay, 1 second. I need to make a little change. I'm going to add the static modifier to my variables up above because I'm using them in a static context. What that means is I do not need to create an object of driver to go through this prompting. That's kind of the Cliff Notes version of this. Okay, so back down, trip 0 equals int distance. Now here's the problem. If I were to run this, I could enter as many trips as I want and they would all store on that ground floor because you see this number 0 is a constant, which is not a good idea. It shouldn't always be 0. What I should do instead is take advantage of that companion variable I created above called trip counter. And so what I'm going to do is after I add something to this trips array, I'm going to increment trip counter. Okay, remember that increment, the plus plus that follows, trip counter. Okay, so I'll just say add 1 to the trip counter to increase our total number of trips entered. Now, if you remember trip counter, it's going to start at 0, and every time we loop now, we're going to add 1 to it. Okay, so first loop is going to be 0, next one 1, next one 2, then 3, 4, all the way up to however many we go. Okay, that's going to make for a much better number to place into this array square bracket than 0, trip counter. Because every time we loop, trip counter will be a different number. It will be one greater than the number it had before. And at this point, we have what we need to collect a series of trips instead of just one trip. Okay, time to fix our method up above now. Do you see here we have we have the prompt for trips that we've just refactored. I'll go ahead and save. I get a little nervous if I don't. Now, what we're doing here is we're iterating over a collection of vehicles that we've created previously. And right now it assumes that we're only going a specified distance. But you know what? We know now that we are iterating that we have multiple distances we want to travel, multiple trips we want to make. I want each car to go on each of those trips. So I need a loop within a loop. Now we saw the for loop before. The for loop is good, as the for each in this case. The for each loop is nice if you have a collection of items you want to shake hands with, and you want to shake hands with one at a time. What's going to happen is this loop will execute once for each item in this collection. And each time it loops, it's going to take one item out of that collection and store it into this local variable, and then we can act on this local variable within our loop. Next time it loops around, a different vehicle goes into this variable. Okay, so what we're going to do now is we're going to put a for loop inside of this for each loop. Let's try that. For uses that same start word, just a different syntax inside. First, we have the initialization part, which is where we'll initialize a variable, int I equals 0. This variable is only alive for the scope of this loop. After the loop's over, variable goes away. Now we have a test. The test is how often do we want to loop? We want to loop once for each trip that we've entered. Where are we going to know how many trips we've entered? Well, remember our friend, the trip counter. Okay, so I less than trip counter. Now be very careful with this. Notice I did less than, not less than or equal to. That's because the trip counter is always going to be one number larger than the number of spaces we've taken in the array, because you notice that we increment after we store something in the array. In Java, you will typically see this syntax. We'll start the counter variable at 0, and we'll use the less than comparison. If you see someone starting a counter variable with 1 and then using less than or equal to, that's not very common. You kind of want to make sure that you're doing that on purpose if you're doing that. Okay, finally, we have the increment part. Down here in our do while, we increment our counter within the loop. In a for loop, we have a special place where we can do that, where typically that's kind of a given that we're going to increment something, and that's the third part of this for loop parentheses is the increment part, I++. So just like how we increment trip counter each time we iterate the do while loop, in the for loop, we're going to iterate this I variable each time we loop around this for loop. Now, I haven't given scope, I haven't given boundaries to this for loop. And if I were to save now, I'd be in a lot of trouble because this for loop, the outer for loop, has an open and close curly. The inner for loop does not. So I want to run each car over each trip. Now, one trick is I don't necessarily need to print before and after each trip. I want to print before I run the car all of these trips, and then after I've run the car all these trips. I could really do it either way. And I'll tell you what, for this first demo, we'll go ahead and print before and after each time we loop. So open curly, close curly. Now notice my tabs are out of balance, and when I'm grading, I'm looking for neatness. So I want to make sure that the tabs are properly indented. So Shift-Alt-F indents the tabs properly, and we're looking a lot better. Okay, now we need to take care of our red line here, which is the distance we want each car to travel. So I'm going to use the array called trips, the one I'm populating on line 100, trips, and then once again, I don't want to hard code in a 0 because then we're going to run each car only the first trip. What I want to use is a number that's going to increase as we're working through this loop. So I will use the variable I, which remember, this increment part, that means we're going to add 1 to I every time we loop. Okay, let's save, and let's just do a quick run, just running it as it is. And then after that, we'll take a look in the debugger. So right click, and I'm going to choose run. And this is the part we've done before. Enter gallons of gas, so we'll do 10, miles per gallon 10, odometer 10,000. Do you want to enter another vehicle? Yes. Gallons of gas 20, miles per gallon 20, odometer 20,000. Do you want to enter another? Yes. Gallons of gas 30, miles per gallon 30, odometer 30,000. Do you want to enter another? No, that breaks me out of the loop. Okay, enter a distance to travel. We'll say 30. Do you want to enter another trip? Yes. Enter a distance to travel. We'll say 40. Do you want to create another trip? Yes. Enter a distance to travel. We'll say 50. Do you want to enter another trip? No. Okay, now we take a look at the output, and what we'll see is we have our tens car, the one that started with 10, and you see that that's running 3 trips here. Then we go to our 20s car, the one where we did 20,000, and that runs 3 trips. Now we ran our 30s car, and that ran 3 trips as well. Okay, so a couple of thoughts here. Number one, notice that our 10s car runs out of gas. In our next video, we'll talk about how to handle that situation and how to prevent it from doing any more iterations within that loop. But one other thing to think about, how many befores do you count here, or how many afters? In other words, how many of these before and after blocks do you see? Well, okay, you see 9. And why do you see 9? Because it's multiplication. This outer loop is going to run 3 times. Each time that outer loop runs, the inner loop is also going to run 3 times. So it's 3 times 3. Now, we happen to be looping over 2 different things. One is a collection of vehicles. The other is a collection of trips. They just both happen to have 3 items in it. But think about this. What if we're sorting a list, putting things in order? Okay, a lot of times we're going to be having one of these nested loops. And in a case where we're sorting an item, maybe putting things in alphabetical order, numerical order, in those cases, the collection is going to be the same. And then what's it going to be? It's still going to be the number of items in this collection times the number of items in this collection. However, those 2 are going to be the same collection, so we can use some shorthand and say that's going to be the number of items in the collection squared, or n squared. And this is where we start thinking about a notation called big O. And you see here this purple line is O(n squared), which is what we were just looking at in our nested loop. Now, you'll see more about big O when you get into the second part of computer programming, but a lot of it's about algorithm efficiency. So in other words, you have a number of units on this axis, that could be number of people, amount of data, something like that, and you have time on this axis. And big O notation is telling you as this axis grows, as your x-axis grows with either data that you're iterating over or people or whatever, how will the performance of your application degrade? The ultimate goal is to have O to the 1 like this, where there's no degradation. But a lot of advanced computer science is looking at how to take a curve like O(n squared) and try to flatten it out. And in the case of sorting and searching, there is a way that we can take O(n squared and we can drop it down to O log n, which is something called recursion, which we will talk about next semester. Nonetheless, I'll tell you this, when I was an undergrad, I was never exposed to this big O chart. It was only when I started at UC and I taught data structures and algorithms that I saw this chart. And I really enjoyed it. Very mathematical, very intense, but I really enjoyed it. It very much applies to computer programming concepts today because we have to consider that a lot of times when we're programming, when we're writing programs now, it's on a memory-constrained device, or there's some kind of constraint. There's always some kind of constraint. It could be a mobile phone with limited memory, processor, and battery life, or it could be a server where you're trying to get as much done on that server as possible before you have to throw new hardware at it. So a really neat concept, one that we're not ready to talk about in great depth yet, but nonetheless, one that I think you'll enjoy when you get to that. I did. So what we'll do now is I'm going to simply set a breakpoint in the prompt for trips so that we can watch the array grow. Let me make sure I don't have any other breakpoints that are going to get in our way. It doesn't look like I do. But I want to take a look at the, I want to watch how this array is going to grow. And once the video is off, I need to take care of a couple housekeeping steps. Honestly, we no longer need that return. Additionally, I desperately need to put some Javadoc up here, so I'm just going to put a placeholder so I won't forget to do that. But let's go ahead and save and debug, and let's take a look. It's going to continue to prompt us as it has before. We'll just enter one car this time. So 20 gallons of gas, 20 miles per gallon, and 20,000. Do you want to create another vehicle? No. Okay, now you see the Pepto-Bismol colored line has turned green, and that means that the debugger has now caught and it's waiting for me to give it an instruction. The program is going to wait until it gets instructions from me before it progresses. Let me expand here and take a look at this thing called trips. Do you see how trips has 100 floors basically, 0 through 99, and all of the values are 0. Additionally, trip counter is 0. Let's monitor these as I walk through this. So we need to debug, and I'm going to choose F8 to step over. So F8, enter distance to travel, we'll say maybe 50. Okay, F8, and now take a look. It's taking this variable int distance, which is 50. It's assigning it to the 0 floor or the 0 element of the trips array. So after I execute this line, we should see this number 0 turn to 50. Okay, and sure enough, there we go. You notice even it's in bold to tell us it changed to 50. Now we're going to increment our trip counter, which is that companion variable, and say, okay, we've entered one trip. And sure enough, you see now that says 1. Okay, F8, do you want to create another trip? Yes. Okay, F8 again, F8 again. Enter distance to travel, let's say 1, or let's say 60 this time. And okay, and once again, it's going to go through the same steps. We're going to see the trips array. This next floor is going to change from 0 to 60. And trip counter is 1. 1 matches the address of this floor. That's why we're going to see that number change to 60. So F8, F8, and sure enough, there you see 60. Right down here in the debugger, F8, F8. Let's do just one more trip and then we'll call it a day. Okay, enter distance to travel, let's say 80. Okay, F8, F8. There you go again, take a look. Number 2 now has 80 in it. Trip counter, we increment our companion variable, and it now says 3. At this point, I'm comfortable with how the program is running. So I'm going to tell it to continue to run. I say no. And if we take a look at the output, we will see that our 20s car has now run 3 times, once for each of those trips. So that's all for this video. In our next video, we're going to take a look at, well, let's see, we looked at arrays, we talked about array lists, we looked at loops within loops and saw how that related to big O. In our next video, we're going to take a look at the break statement, and then in a future video, we'll take a look at multi-dimensional arrays. We'll see you then.